Hi everyone. We're going to go over the first part of 5-1. We did this in class. It was properties of exponents. But just to go over the examples they have in the book, we're going to head and have its own little video. So here are the properties of exponents that we're covering. We have product of powers, which is where we multiply two terms and they have the same base, so we add the exponents. Then we have the quotient of powers, which is where we're dividing two terms. They have the same base, so we subtract the bottom exponent from the top exponent. We have the negative exponent property. So this will let us get rid of the negative exponent by moving it either to the numerator or denominator, depending on where it's located. We then have a power of a power, which is we're raising the exponent with another exponent. So we're going to multiply the exponents. And then a power of a product is just us distributing an exponent to all the terms in a set of parentheses. And power of quotients doing the same thing, only we're distributing the exponent to both the numerator and denominator. And then our zero power exponent property that says anything to the 0 power equals 1. So when we're simplifying monomials, which is one term, we have a couple things. There are no powers of powers, meaning we have no parentheses whatsoever. Each base appears exactly once, and what we mean by that, it means we only have either one coefficient and one letter of every time of that, a single existence of a letter for a variable. All fractions are in the simplest form, and there are no negative exponents. So taking a look here, we have simplify the expression a to the negative 3, a squared, b to the 4th times c to the negative 1, and we're going to assume none of the variables equals 0. So we're going to take our original and we're going to head and use the definition of negative exponents. So we're going to move things to the denominator. For a to the negative 3, a is now 1 over a cubed, and c to the negative 1 is now 1 over c. So by definition, this is actually, we're expanding everything out here. And this is one of the reasons we like the properties of exponents, is because we don't have to expand everything out if we use these definitions and these properties. So they expand it out to show you exactly what that previous line represents. And then we're going to divide out common factors. So meaning that is something I'm multiplying and dividing by, I can cross out a pair, which simplifies to 1. And we're left with 4b in the numerator, so b to the 4th, so b times itself 4 times. And then we have 1a and a c in the denominator. So b to the 4th over ac is our solution. Another example here is we have n squared over n to the 10th. We can use quotient of powers, so we're going to do 2 minus 10 to get negative 8, but we do not like negative exponents, so we use the negative exponent property to get 1 over n to the 8th. And as always, pause the video as needed if you need more time to write or review what happened. Next, we have 3a cubed squared over b to the 4th. With the squared being on the outside. So the first thing we're going to do is the power of a quotient, which distributes the exponent of 2 to both the numerator and the denominator. And then we're going to use power of a product to distribute that exponent, this exponent of 2 to both 3 and a cubed. And we simplify to get 9a to the 6th over b to the 8th, which is our power of a power, and that is our solution. All right, so go ahead and pause the video and give this problem a try.
It is now the beginning of D-lunch.
Sorry about that. So if you work this one out, you should get C. And you're going to get C because, let me go ahead and get the pin out. I have x to the negative 2, x to the negative 3, y to the negative 3, y to the 5th, and z squared. So when the hint's z is by itself, so I know I'm going to leave z squared up in the numerator, which crosses out a and d. both of these are negative, and negative 2 minus 3 is x to the negative fifth. But that gets me 1 over x to the fifth because of negative exponent property. Negative 3 plus 5 is y squared. So that stays in the numerator, and we keep our z squared in the numerator, which when we add that all up, we're going to get y squared z squared over x to the fifth. All right, go ahead and try this problem. Unpause the video when you're ready to move on. All right, so what we have here is we have a negative 2, so using negative exponent property, that would move to the numerator. Using a product of powers, I'm going to add my exponents to get h to the 8th, which is a. And for our last example, or you try, go ahead and unpause the video when you're ready to see the solution. All right, so we're going to head and distribute the exponent of 2 by using quotient of powers. That gets us 6r squared in parentheses squared, in parentheses 3s cubed squared. We then use power of a product, and distribute the exponent to both what's on inside the parentheses. So we get 6 squared and then r squared squared over 3 squared and then s cubed squared. And by simplifying this, we're going to get 36. And using power of a power, we get r to the 4th, because 2 times 2 is 4. 3 squared is 9. And then 3 times 2 is 6. And we can simplify this even further, because 36 is divisible by 9, and we get 4 r to the 4th over s to the 6th. So my answer is C. That is the end of this video. This was just a brief overview of properties of exponents that we did actually in class. Next time I will go over the operations with polynomials. So I will see you next time. Bye.